Alright, in this video we're going to go over every single problem that was on the worksheet that looked like that. These are my master copies. You were given plenty of time to do this in class. If you didn't finish this, you were supposed to do this for homework, so hopefully everyone is done with this, right? And if you are finished as you're supposed to, check your work against my solutions, and if anything is off, even if you think you got the right answer or you did the work correctly, ask me. That way we can compare, maybe use a different method. And even though it worked, there might be a more efficient method. And if you didn't do the work, sure didn't finish it, first of all, shame on you. Second of all, at the very least, write it in as the video goes on, so at least you do have something to show me when I collect your interactive notebook. That being said, let's go ahead and jump in. We are going to start with number 1. Which is 5y minus 3 plus 2y plus 1 equals to 12. This is a pretty simple problem. Essentially, here it's a multi-step equation, 3 steps. Step 1, combine your like terms. Step 2, get rid of something to isolate the x. Step 3, get rid of the other thing to finally isolate the variable, not the x, the variable, and you're done. Step 1 though, combine your like terms. Why? Because you can't really solve for y here until you only have one y. You have 2 of them there. And while you combine your y's, you might as well combine your other like term. So those are y terms. And then we have constants. I'll go ahead and mark this one off too, but again, we're not going to be able to combine this constant with the other constants because they are separated by an equal sign, this being an equation, and that equal sign acts as kind of like a wall between them. Alright, so that being said, 5y plus 2y, we ignore this minus because that minus goes with the constant, it's in front of the constant. So 5y plus 2y, that gives us 7y. And then with the constants we have, technically this is minus 3, but because this minus sign is in front of the 3, we're going to think of this as a negative 3 plus 1, so that's a negative 2, minus 2 here. All of that equals to 12 because we can't really do anything with this constant. While it's a constant, just like the other two, it's off on its own side of the equation. If there was something else here, we could have worked that out or combined that, but it's alone on its own on that side of the wall, essentially, all alone. Alright, now it's a two-step equation. All we have to do now is isolate y. I gotta get rid of this, the minus 2, or this, times 7. And I gotta choose one or the other. Which one do I choose? The one that's further away. That's a 2. Alright, so on the left side, minus 2 plus 2, that's gone. And on the right side, we have 7y equals to 12 plus 2, which is 14. Alright, good. So what's next? Last step of the equation here, get rid of the multiplied by 7. What's the opposite of multiply by 7? Well, it's divide by 7. And again, both sides, don't forget that. And once I cancel that out, 7 in the numerator, 7 in the denominator, you simplify them to 1. 14 divided by 7, y equals to 2. So make sure you have that as your final answer, y equals to 2. And you can easily check to see if that is the correct answer by plugging in the solution to 2 and for the y here and here, crunch your numbers, and it should all end up being equal to 12. If it's not, something went wrong. Alright, I'm going to move on to number 2. Ask me to pause here if you have any questions. pretty similar to the problem in number 1. Okay, I'm going to go through the same steps as I had before because this is a very similar type problem. So I'm going to combine my like terms first, because if I want to isolate for x, I need one x term, not 3x terms, because that can get a little bit weird. X terms. And then I have my constants, which I won't be able to do anything with in terms of combining or simplifying because they're on different sides of the equal sign. So I can't combine the 9 and the 33, even though they're both like terms. Alright, 6x plus 3x, that's 9x. 9x take away an x, that's 8x. So once again, 6x plus 3x, 6 plus 3, that's 9. 9 take away just 1x, and remember, pretend there is a 1 in front of that. 9x take away an x is 8x. And then I have plus 9 equals to 33. Okay, terrific. Two-step equation now. I got to isolate the x just like I had to do over there. I have to get rid of plus 9. I have to get rid of times 8. I got to choose one or the other, and I always choose the one that's further away if I can help it. The opposite of plus 9 is minus 9. That's why I subtracted the 9. On the left side, plus 9 minus 9, they're gone. On the right side, 33 minus 9 is going to give us a 30. That's weird. So that's going to be a 34. Okay, I think I did this problem correctly. I did. Because that's not going to come out evenly. Oh well. So we have 8x equals to, 34. That's unfortunate. That's okay. We can make that work. We have here a single step equation now. One thing left to do is to get rid of this multiplied by 8. What's the opposite of multiplied by 8? Divide by 8 on both sides. The only problem here, and I'm going to draw an arrow continuing on, is that, well, I can simplify these down to 1. That's good. The x is left on the left side. But on the right side, I have 34 over 8. And while I don't mind in proper fractions, that doesn't concern me, this is not in simplest terms, which I have to get it into simplest terms. That I will require of you. How do I do that? X equals to, I'm going to break out the 34 into 2 times 17. I did my math correctly, right? That is a 34. Yeah. I was hoping it would be a 32, then that would make a very easy division here, but oh well. And the 8 is 2 times 4. I know I can break down the 4, but I'm not going to because I don't need to. And then I'm going to simplify, cross out things that are the same, top and bottom. I have a 2 I can get rid of top and bottom. So my final solution is x equals to 17 over 4. Not as clean of an answer that I would like. You know, it's not a whole number, and you can of course write that as a proper fraction as well. If you want that, you go ahead and do that, but not as clean of an answer, which makes it a bit difficult to check your work. But nonetheless, that looks like a reasonable answer to me because our work seems to be reasonable. I don't see any major mistakes in it. If there are, point them out. I'm still getting over my flu, so anyways, moving on to number 3. Number 3, we have a slightly, no, not really, it's still the same type of problems. So we are going to be solving them in the same way. Equals to 5x, so 29 equals to 5x plus 21 plus 3x. Very similar to the problem before this. And the only trick here, if anything, if I threw you off, is by having my variables on the right side. Normally they're all on the left side. Makes zero difference. Solve it just like you would any other problem. It doesn't really matter if the variable's on the right or the left side of the equal sign. So I'm going to combine my like terms because I have two x terms and I want them combined. I do also have a pair of constants, but I can't do anything with them because they are separated by an equal sign, which acts as a wall. It's like a mathematical wall of sorts. Not really, but you get the point. Which gives me 29 equals to 5x plus 3x. That's 8x plus 21. All right, now we have a two-step equation. Isolate the variable, isolate the x. I want this all alone, which means I need to get rid of this. I need to get rid of that. I have plus 21 times 8, and I'm going to choose the one that's further away. Plus 21. What's the opposite of plus 21? Minus 21. Inverse operations. And of course, I got to do that from both sides to keep the equation balanced. I'm going to put an arrow here, continuing on. On the left side, 29 minus 21 is 8. And on the right side, we have 8x, and that's it, because plus 21 minus 21 cancel each other out. All right, terrific. Now one step left, and it's a real easy step. I need to get rid of the multiplied by 8. What's the opposite of multiplied by 8? Divide by 8. And on both sides, in this case, I get the 1. Not a 0 though. Remember, I'm not making the 8s disappear here. 8 divided by 8, that's 1. 8 divided by 8, that's 1. So I'm not going to write the 1 over here because 1 times x is x itself. But here I'm going to keep the 1 because there's nothing else. So I can't write a 0 because 8 divided by 8 is not a 0. So my final answer is x equals to 1. So x equals to 1. Again, I could write the 1 in front of the x here if I really wanted to, but I'm not going to. But here I have to keep the 1 because if I don't, there's nothing else there. And I know it's not a 0. All right, that was number 3. Ask me to pause this if you have any questions, but I am going to move on to number 4. In number 4, we have a problem that's, again, pretty similar to what we've done so far. You can probably imagine that bulk of the quiz is going to be problems like this. At least half of the quiz will be, well, not half of the quiz, but at least 2 problems from the quiz will be problems of this type because I'm concentrating a little bit more on these guys. Anyways, this is pretty much just like the problem before. This one has 5 total terms. Makes no difference because we still have 2 different term types. I want to combine them. I have the m terms. Combine those. I have the constants. And I'm going to try to combine those. Remember, I can't combine the 31. Even though I marked it, it's on the other side of the equation from the other 2, so I can combine these 2, but not this guy. Alright, let's start with the m's. 7m take away an m. Again, this is just 1m, so 7m take away 1m, that's 6m. And then 6m plus 9m, that's 15m. 7m minus m, that's 6m. 6m plus 9m, that's 15m. I ignore this minus sign because it belongs to the constant. And I'm not dealing with a constant yet. I'm going to now, though. What's a positive 2? Take away 1. Just 1. 2 minus 1, essentially. So plus 1 here. All this equals to 31. Now I am at the 2-step equation stage. I have to isolate my now 1m. And I need to get rid of this and this. I'm going to choose the further term first. What's the opposite of plus 1? Minus 1, the inverse operation, and of course I'm going to do that to both sides. So I have 15m, and then canceled out. I mean, plus 1 minus 1, that's 0. That technically canceled out. And 31 minus 1, that's a 30. Last step, I'm going to get rid of the multiplied by 15. What is the opposite of multiplied by 15? Divide by 15. And over here, 15 divided by 15, that simplifies to 1. I still have that 1, but I'm not going to write it because 1 times m is m itself. And 30 divided by 15 is 2. Nice and clean. You can easily verify your answer by plugging in the 2 for the m here, for the m here, for the m there. You can also plug in this 2 into this equation here as well to check, because this is the condensed form of this equation. But either way, if you plug in the 2 here or here and you get 31 as your final answer, you should you know that you did the problem correctly. Alright, I'm going to move on to number 5 now. Ask me to pause if you have any questions. Number 5 is on the back. Number 5 is a little bit different. And why? Because these problems have denominators. Alright, so I have 5 over 8 plus x over 8, all of that equals to 33 over 8. I could, if I really wanted to, get rid of the further term first. Actually, not that one, this one. I could have subtracted 5 eighths from both sides. I could have done that, but I'm not going to, because I think it's easier to get rid of the denominators from all of these problems first. So make sure there are no fractions here. And how do I do that? They all have the same denominator, which makes it easy. If I get rid of one of them, I'll end up getting rid of all of them. Denominator means being divided by. I'm dividing by 8. What is the opposite of divide by 8? The opposite of divide by 8 is to multiply by 8. And I'm a little short on space here. Hopefully you guys can see that. So I'm multiplying everything, the entire equation, by 8. Why do I multiply the entire equation by 8? Because if I multiply anything by 8, I have to multiply everything else by 8 as well to keep the equation balanced. If you remember that, I got to do it to both sides. And the neat part here is that because they all have the same denominator, once I get rid of one, it'll get rid of all of the others. First step though is to distribute that 8, which means I have So I'm going to distribute my 8 first. So that times 8. That times 8. That times 8. And whenever you multiply a number by a fraction by anything, you're assuming that whatever you're multiplying by goes into the numerator. If you need some visual help, you can always just put that 8 over 1. It's the same thing. 8 over 1 is 8. But that just shows you that this 8 is on the top and not in the middle or on the bottom. Alright, then I can cancel things out. I have an 8 at the top and an 8 at the bottom, 8 at the top, 8 at the bottom, 8 at the top, 8 at the bottom. So I did what I set out to accomplish. I got rid of all my denominators. What's left? Here I have a 5, plus here I have an x, equals here I have a 33. Perfect. If you have any questions right now, if this is confusing, ask me now. I'll pause this and explain it again. But if this makes sense, let's go ahead and move on. Now this is a single step equation. I got to isolate x. The only thing that needs to be taken away is that 5. And it's being added to the x. What's the opposite of being, well, what's the opposite of adding 5? It's subtracting 5 from both sides, of course, to keep the equation balanced. It's the name of the game. That's why I multiplied both sides by 8 there, to keep the equation balanced. 5 minus 5 is 0. That means I have x now, positive x, so x. 33 minus 5, that's 28. That's it. And done. You can always check your work by taking this 28, plugging it in over here, and once you crunch your numbers, everything works out. You should get this answer. Alright, moving on to number 6. Six is very similar to number 5. Very, very similar. We have 3 over 5 plus m over 5 equals to 14 over 5. So again, very similar problem to what we already did. I have fractions. I don't like fractions, so I'm not going to take this away. I'm not going to start isolating for the variable first. I am going to get rid of all my denominators. And since they're all the same, very neat, again, because if I get rid of one, I get rid of them all. So how do I get rid of any of them? They're all being divided by 5. So the opposite of divide by 5 is to multiply by 5. And of course I got to do the same thing to both sides, which again is convenient because it's going to take away all of my denominators in one swoop. I'm going to distribute this 5. It's my first step. And again, if it helps you, you can put that 5 over 1. You don't have to, but it just visually helps you realize that that 5 is at the top, not at the bottom. You don't have to put this over 1. It could just be the 5s that I had on the previous step. Alright, that being said, now I can cancel things out. 5 at the top, 5 at the bottom, 5 at the top, 5 at the bottom, 5 at the top, 5 at the bottom. Conveniently, all my denominators are gone. What's left is this 3. Technically it's 3 divided by 1, but that's just 3. The m, again m divided by 1, but that's just m. And the 14. Last step, isolate m by getting rid of this. Plus 3, what's the opposite of plus 3? Minus 3, from both sides of course. Which of course means that m equals to a simple 11. You can easily check your work by plugging in the 11 for the m here. And after you crunch everything out, it should equal out to your answer. Alright, if you have any questions, ask me now to pause this, because I'm going to move on to number 7, which is a bit tougher. Alright, number 7 is coming up next. So number 7 is kind of similar to the previous two, but it's a bit more challenging because it has this problem. Let's see here. Sorry, some technical issues with my camera. And the trick here is that you have denominators like you did in the previous problems, but they're not all the same. I'm still going to get rid of them, but it's going to take me an extra step. And that extra step is finding the LCD. So I want to do that first. You can also do the common denominator, but that's going to be a lot of work. Just like before, the LCD is the preferred method. So find the least common denominator between all the denominators present. I'm going to start with a 7. 7 itself, 14, 21, 28. Then I'm going to choose one of the 21s because they're both the same. 21 itself, and then 42. Then it's going to be 63. But I don't need to go any further because we already found one. We found our LCD, which is, in this case, the 21. Makes it convenient because one of the denominators is already the LCD. So what do I do next? I found my LCD. Terrific, it's 21. Well, to get rid of the denominators, you multiply both sides by your LCD. So I'm going to multiply all of this by 21. I'm going to multiply this by 21. And it's going to make sense in a second why I did that. Alright. Because and the reason I'm doing this, I want to multiply it by something that's going to help me to get rid of all the denominators. If I multiply it by the LCD, I know that the LCD will contain the denominator number inside of it, which means I will be able to eliminate it. Even if I have something left over with the numerator. That's fine if my numerator becomes a little bit bigger, because my goal is to get rid of the denominators. And in the case of these two guys, it's going to be an even swap. Here I'm going to have a bit of a leftover in the numerator, but that's fine. A bigger numerator doesn't concern me as much as having denominators. So fractions are, if you can get rid of fractions, that's your number one priority. First I want to distribute that 21. So I have multiply by 21, and again I can put that over 1 here if that helps you visually. Mathematically it doesn't make a difference. You can just keep the 21s where they are. Just remember that that 21 is in the numerator position, not anywhere else. It's not in the middle. Alright, then just for this problem I'm going to break up my 21, and you'll see why in just a second. So the 21 is 3 times 7. And I want to just carry these guys over just for one step because I just want to work on this one. Over here, I can cancel out. The reason I broke this 21 into 3 times 7 because now I have a 7 at the top and a 7 at the bottom. That's the only thing I can cancel out, but it's enough because it gets rid of my denominator. I have that 1 now, but divide by 1 is the same thing as the number itself, so I don't have to worry about it. On the top I now have 3 times 6, which is 18x. Okay? Over here, I don't have to break anything up because I have 21 at the top, 21 at the bottom. They cancel each other out. Same thing here. Makes it super convenient. So if I just keep bringing it down, I'm left with 2x with that minus equals 2. I'm just left with that 25. Perfect. I'm almost done here. My second to last step is to combine like terms. I have two x terms. I'm going to go ahead and combine them. Which gives me 18x minus 2x is just 16x. If I did my math correctly. And it seems like I did all my math correctly, so the reason I'm not liking this is because I'm going to get a fraction for an answer. But that can't be helped. My last step is to get rid of this 16. It's times 16, so the opposite is to divide by 16 on both sides. I can cancel out here 16 and 16, that's a 1, so I can ignore that. And I will write my answer right over here. So my final answer is x equals to 25 over 16. I can put that as a proper fraction if I wanted to, but I can't simplify it any further. Because that's 5 times 5 and that's 4 times 4. So Yep, that's the right answer. It took us a little bit of work, but it wasn't too bad if you just followed through every single step. And on the quiz, if I give you a problem like this, I'll make sure that it actually simplifies down nice and even. Alright, last problem, number 8. Here we go. Oh, and if you need me to pause this and explain some parts, let me know. Number 8. Almost there. Number 8 is a word problem, and it says, Linda is paid double her normal hourly rate for each hour she works over 40 hours in a week. Last week she worked 52 hours and earned $544. What is her hourly rate? We don't know that, right? So I'm going to say that the hourly rate, our unknown, is going to be a variable. We don't know it. So in math, whenever we have a word problem and we don't know what that particular term is, we just give it a variable. I'm going to choose H. You can choose an X or R or whatever. Hourly rate, I don't know. H makes sense to me. Or maybe R for rate. Whatever the case. So now we know that Linda is paid double her normal hourly rate for each hour she works over 40. Okay? In a week. Last week she worked 52 hours. So what's 52 take away 40? That's 12. Why is this important? Because 12 is the number of hours that Linda worked over 40. And remember, if she works over 40 hours, she gets paid double her rate. Okay? So this is how we set up this problem. So Linda worked 40 hours at her normal rate. So we're going to write that as 40 hours times her normal rate, whatever that may be, her hourly rate, times H. Okay? Then she worked 12 hours, so an additional 12 hours, but she worked these hours at double her rate. So double the H, or 2H. And all of this equals out to $544. That's how much she earned total. So now they want us to find the H. That's not so bad. Once you have everything figured out, that's actually not a bad problem here. Because all you have to do is 40 times 8, that's 40H. 12 times 2H, that's 24H. 12 times 2. All of that equals to 544. Now I just have to combine my like terms because I have two H terms here. And 40 plus 24, that's 64H. That equals to 544. And now it's a single step equation. I just need to isolate my H, my hourly rate. How do I do that? I get rid of this. 64 is being multiplied. What's the opposite? What's the inverse operation? Divide by 64 on both sides. And H is the answer to that division right there.